Good evening, everyone. So I'm your host for today. My name is Ankit Mittal, and I'm going to cover this session for you today. Okay. So before starting, I would like to introduce myself. Okay. So I'm having more than 10 years of experience in the field of DevOps now, and I have been actively working in the companies which are like into the various domains. The companies that I have been working on, this majorly includes the financial domain companies, the companies like in digital marketing. Then there are companies which are working in the education domain, IoT based, that's Internet of Things based companies. And then I have also worked with some of the companies and projects which are into the medical domain. So it's a diversified background of the companies that I hold and the projects that I hold experience. Okay. So what is the common amongst all these companies was that they all desire to implement the cloud and the DevOps practices in the organization in order to significantly improve their business process at the same time their offerings as well. Okay, and this is what our core thing for today is. So we are going to look into some of the advanced technologies like that of Kubernetes and try to understand what is exactly the DevOps is. And we are also going to cover the architecture. And then finally, we are going to conclude towards the various kind of services that we are having. So it's going to give you an overall aspect towards the learning on how the industry is progressing and how far we have come in terms of the technology. So whatever we are going to cover today, this is like the this is all the latest technologies which the companies are leveraging to provide you the cutting edge applications that you might have already been using on your mobile and the web platforms. Okay, so let's get started with. All right, so first of all, about the Cognixia, we are the world's leading digital talent transformation company. Okay, so if you look towards the Cognixia, it's we are basically the authorized training partner with all the major companies out there. Okay, like Red Hat is there. Okay, Microsoft, ITIL. So we have like trained more than 1,30,000 plus professionals worldwide, and various organizations have recognized our contribution towards the work that we have been doing. And the Cognixia is providing the training in all the major technologies out there. These are all the latest technologies. So we are focusing on DevOps, which is like the company standard for now and heavily focused. So all the other technologies, basically the DevOps would always be there. And these are the people who are like, significantly impacting on how the applications are getting delivered in the shortest period of time. So if you move towards this field or you are already working in this field, okay, in both these cases, you will see that there is a significant amount of collaboration with the DevOps people and how they are working. So there is a keen interest and they are involved in a lot of process and automation, which is really helping the businesses to achieve their goals. Okay. And then, so you can enroll for any of these services. Okay. The topic that we are going to focus, the main agenda for us is to understand this DevOps ecosystem as a whole. So what exactly contributes to these DevOps? Why is there is so much thrust? Why the companies are readily adopting it? Why they are migrating from their initial approaches towards the DevOps? Okay, so we are going to understand all of this ecosystem as a whole. Okay, now everyone, I would like to brief you here that we are going to focus, okay, mostly on the initial 1 hour is towards understanding this DevOps ecosystem. So I'm going to brief you everything about it and all the related technologies, tools, which basically helps in implementing the DevOps effectively in your organization. Okay, and after that, I will be focusing, we are going to have a dedicated Q&A round. So there is a questions window which is available in your GoToWebinar control panel. You can type your question there. I would be really happy to answer all your queries. Okay, so we are going to have a 30 minutes dedicated Q&A session. Okay, so you can resolve all your queries. All right, and if anyone is facing any issues with the voice or something, I would suggest you to check your speakers. Otherwise, you can join in back. That should resolve your problem. Okay, so let's get started now. All right, so starting with the DevOps, okay, this is a very key term right now in the software industry, and most of the teams are like trying to move. Most of the organizations are trying to adopt the what we call the DevOps practices, which is into the software development, which helps them move ahead really fast. Okay, so what exactly is DevOps? See, the DevOps term came into picture back like back in the 2010. Before that, it was like there was separate development teams and then operations teams. These two were the dedicated teams which was looking into their separate domains. Okay, and this is where the term originated from. It's basically originated as a combination of dev and ops. So people, the DevOps was, it's kind of a, you can think of it like an approach which helps you to deliver the features in your applications much more quicker. So, and it helps in organization release the fixes and updates in their application very frequently. So basically what happens is these are the people which basically break the silos. So initially what was happening in the organization, that there were two separate teams. Dev people were responsible for development. Okay, so they used to code and their main focus was in getting these new features. So they were like heavily focused and their key area of focus was towards the development of the new features. Now this was their sole feature. They were not thinking how this is going to run, or what kind of infrastructure that we are having, which whether we are designing our application according to it or not, or what are the significant challenges that we are going to face in terms of scaling the application. And then there were operations people who were mostly focused towards the operation side. That is, they were more concerned about how they are going to run their servers, how they are going to implement their patches, security, and these kind of stuff. Now, the problem was that they both were not in sync. Okay, though both were heavily inclined with each other, because whatever the developers were developing, they are going to run on the systems, and the systems has to be designed in such a way that they are capable of running the applications, and they should take in the high availability and the scalability in approach at the same time in order to effectively run the application. So think of it like, let's say, and we are having an e-commerce platform, and tomorrow we host some major event due to which we expect that our traffic is going to increase 10x time. Okay, so if our infrastructure is not able to handle that kind of traffic, the entire whatever be the efforts that has been put by the organization, they are not able to achieve it, right? And this is like both the teams are equally responsible. So this thing was realized, and this is where the DevOps basically came into picture in order to solve this problem. So DevOps was taken as an approach through which you can overcome this issue that the dev people are working in their own silo and operation people are working in their own silo. So it was an approach to basically try to create approach towards the creating it as a single approach, so that both the teams are in sync. Okay, the people understand the challenges of the different teams and they are able to propose the solutions, okay, which to overcome this silos issue. Okay, and what was the objective of the DevOps? The main objective was delivering the features much more faster. Now, what was the problem? The problem arises from the fact that operations team heavily focused on infrastructure part. They were like that if the newer features are going to be introduced, the code might not be stable, which is going to cause problem in the infrastructure, and the availability might get affected. So they try to create problems towards the releases. They would ask them for getting various kind of approvals and things like this, and heavily tested before the newer versions can be released. Now obviously this is not very significant towards the business side, because newer features helps in retaining the customers. Okay, this is quite evident if you are using your mobile applications. You would see that there are very frequent updates to your application, and whenever you update your application, mostly it's going to bring some newer feature. Okay, and when these newer features gets implemented in the application, okay, this helps you to you are going to use the application more often for getting those new features, right? And this is what drives the business. And if someone is if the teams are like not in sync and they think that introducing newer code is going to cause issue, this is a problem for the business, right? And similar things can be with the fixes as well. With now, sometimes whatever you have thought of, sometimes it might not work. So you bring on patches, you bring on fixes to it. Okay, so that is also a change, and a change might cause problems. So operations team used to delay these kind of fixes as well and updates. Now, so the main focus was for DevOps was to help in automating all of this stuff so that the newer features, fixes, and updates can be brought on more easily. And this is where we will see that DevOps heavily focus on CI/CD pipelines. Okay, that is the continuous integration and continuous deployment processes, which we are going to discuss later. Okay. All right. So what exactly is DevOps? So right now, as I discussed with you, that the DevOps basically solve the issue between the development teams. Okay, and they so think DevOps like a core package. Okay, like they are the people who are having knowledge of all the three verticals. So whenever you talk about any application, there will be development folks who are responsible for the active development. Okay, these we call as developers. Okay, then there are QA people who are into the testing. Okay, and finally you will see that there are operations people who are like mostly responsible for maintaining the servers and the infrastructure part. Okay, so these are the three teams which are actively working together. Now you will see that whenever we talk about the DevOps people, okay, they are the only individuals which are having a significant knowledge of all the three teams, all the three parts, all the three teams. Okay, now whenever we talk about such three teams, okay, so these people can able to understand what are the issues which the development folks are facing, which is causing them so that they can release their application features much more quickly. Okay, similarly, whenever newer development happens, okay, whatever code is getting released, it needs to be thoroughly tested, and there are different types of testing. Okay, it can be unit testing, it can be integration testing. There are a lot many types of testing which the applications has to pass before it can be introduced in the production. Now obviously the testing was one of the it was one of the field which caused the significant delays, because prior to the introduction of DevOps, all the testing was done manually. So you will see that there were huge testing team. They were testing, doing the different kinds of testing manually, which will cause significant delay in release of the new features. And once the testing results was out, it was shared with the development teams, and then they are going to try and resolve those bugs. And then again, testing team will take significant amount of time, and finally the reports were prepared, and once the things was like resolved, these bugs were resolved with the application, then they are going to release it, right? And this caused significant delay. So all of this tested was automated. Okay, this testing part was automated, and DevOps helped them to integrate these testing with the release cycle. Okay, and every time there was the new features that was released, the testing was done automated, and the reports were generated in a very short period of time, so that if there were some issues, they will easily be identified during the release part. And once these bugs were resolved, then only the deployment part will come in. Okay, so you will see that these the team, which is like the people who are focused on the DevOps side, they are acquiring the knowledge of all the three domains, and they can see all the three domains issues and overcome the solutions for them, so that the organizations can move much more faster. Okay, all right, so let's see the DevOps cycle. Okay, so what exactly is DevOps? See, this diagram clearly explains how we are going to do the application development. So initially you will see that there is a plan phase, and this is where the business teams and business folks pitch in for whatever the solution is being required. Okay, and they hold the meeting with the application team. Okay, and they brief them about what is required from the business perspective. Now, once this planning has been completed, okay, then the coding part comes. And here the brief detailing between the dev team is being done on how they are going to, what models that they are going to follow, what are the architecture of the application look like, which technologies they will be using, which coding language they would be using, and things like that. And eventually the code is going to be run. Okay, code is going to be built around that features that has been discussed with the business team. Now, once the code has been done, okay, then comes the build part. You have to actually compile the code. Okay, now this part is towards the compiling the code, and this is where whatever you have written is going to compile in a form which can be later deployed. So if we are talking about the Java application, it would be compiled in something like a war file or a jar file, which can be deployed in the on the servers. Okay, and it basically includes like downloading all the binaries which are required for running the application and compilation of code. Okay, so this is the build part. And after the build has been completed, okay, then comes the testing. Now, whatever the build has been generated, you are going to run the test cases on it, and you are going to determine whatever feature that is being released, it is having some bugs or not. If there are some bugs, you are going to determine those bugs and going to prepare a report, which would be, again, these bugs reports are basically shared with the dev team. They are going to review it. If there is some issue which has been reported inside the testing, then these folks are going to resolve those bugs. Okay, and after the testing has been done, it goes to the release cycle. Okay, now release, whenever we plan for a release, okay, we are going to start from the initial environments like dev environment, then we are going to move to the QA environment, then to test environment, uh, and then to stage, and finally to production. Okay, so it can be little different. Some teams might be having like pre-prod or user acceptance testing, things like this, but there are different environments in which the release is being planned. Okay, finally, after you are going to deploy it on the servers, these are the production servers. So as soon as you deploy them over the production servers, it became available to your end users. Okay, and then finally, once this has been done, you are going to perform all the operations. If something is required, like restarting Tomcat server or some other operations is required, you are going to perform them. And finally, it comes to the monitoring. Okay, so whatever has been deployed in the production, you are going to put the active monitoring on it, so that if something is misbehaving or not working as expected, okay, then the monitoring is going to raise the alerts for it. And finally, again, you are going to come in the plan phase. Now, this is a closed loop which happens over and over again, which helps in improving the application. Now, you will see that this planning phase is coming from the business side, so obviously we are not concerned with this. Okay, then comes the development side. Okay, so devs are heavily focused on it. Okay, and once they have understand, they are going to work on it. This is where mostly the agile practices comes into the picture. Okay, so developers are going to work according to the agile methodology for implementing these code related changes. Now, if they have to effectively implement the agile practices, now this is where all the remaining parts comes in under the DevOps. So you will see, apart from the code part, okay, the build, the testing, release, deploy, operate, and monitor, everything comes under the DevOps. And you will see that DevOps is responsible for automating all these steps. So eventually what is going to happen is that as soon as a developer has worked on a module and he has like written a module, so as soon as he's going to commit his code, that is, he's going to commit the code inside a repository, final repository, using Git or some other version control system. Okay, so as soon as he commits and says this is his final code, the build should automatically start. Okay, now as once the build has been started, the test cases should automatically run. Okay, and then release part should go in, deployment should happen, and if there are some issues, then it should revert back automatically, okay, without affecting the production. And if everything is going well, okay, then the operations part, any operations that we want to perform should happen, and finally the monitoring should be applied on it. So you will the DevOps is highly like responsible for automating all the parts. So you will see we are going to have learn the different tools in order to automate all these stages of the build and deployment. So you will see that all of these stages you are going to automate under the DevOps, okay? Except the plan and code, okay? Rest of all the things you are going to work under the automation, okay, in the DevOps. All right, so here is a brief history of the DevOps on how the things eventually propagate. So it started with the Patrick DeVos. He was the first to focus on the IT value chains. So what exactly brings the value and how it's going to evolve. And then the agile practices come into the picture 2008. Then Google adopted this agile system of administration, okay. And finally you will see that lot of in 2009 the DevOps came into the picture. It was thought of as an idea on implementing the solutions around the problems which the dev and ops team were facing, and then eventually the tools started to coming, okay. So this is Chef, Puppet, and Jenkins. These were the major tools which initially came way back in 2010, which heavily focus on DevOps practices, okay. And then a lot of other developments started to come in, and eventually this is the a whole timeline for you to how the DevOps practices grow over a period of time, okay. So who all are the DevOps stakeholder? Okay, so we already discussed about the automation part and how the DevOps significantly contributes to it. Okay, so apart from the development, all the other stages are already automated. So you will see that DevOps is whenever we talk about who all are responsible for it. So under the engineering, you will see that there are basically three main teams. Okay, so DevOps are the people who are actually going to collaborate with all the three teams. Okay, they are the from the DevOps QA. Okay, so DevOps are basically communicating with all of them. Okay, and they understand the problem of all of these teams. Okay, and they come up with the solutions for those problems. Okay, all the people who are working in these teams become eventually the stakeholder. And so let's see further how we can implement the effective DevOps for an organization. What are the requirements for it? So what are the goals of DevOps that the DevOps basically helps to address? Okay, very first thing is help in improvement of deployment frequency. So what is exactly a deployment? Let's say I come up with a feature. Okay, so everyone is using, I believe everyone is using the WhatsApp, right? So if you will see that initially WhatsApp started just as a for a chatting purpose, that you can send a message on it, okay, and nothing else. So initially it started a way as an alternative to the messaging. Okay, we used to send the messages which used to cost some money. So they developed the WhatsApp and they just released with this feature only. Okay, now over a period of time, as soon as it started gaining the popularity, we started to have the file sharing into it. Okay, then we have the functionality to share pictures, then the functionality to share files. Okay, then videos we can share. Okay, later they introduce voice messages. Okay, so what are all of these things? These are basically the features. So if you look them from the business perspective, okay, you will find that all of these features helped the WhatsApp to retain the customers. Okay, so the customer retention for the WhatsApp is very high, and that's why you will see that it has so many active customers right now. And not only that, they are still bringing on. So they have even adopted the payment strategy into it. Okay, they have created groups, they have created marketing solutions. So this is how you eventually start, and that's why all the companies out there want to introduce these features in order to grow their business. Okay, but whenever you have to include a new feature, you have to go ahead and do a deployment in your production system. Doing a deployment in your production system can significantly affect it if the code is not stable. And if this happens, then your availability might get affected. So there are large number of steps which has to be done in order to do a successful deployment. And if you want to do a successful deployment, this is the primary goal for any organization, as I have explained you how the various adopting of the features helps the organization to grow their business, right? So improving the deployment frequency, this is one of the primary goals, and this is where the DevOps uses the various tools to overcome the challenges towards these deployment and help in organize achieving this goal. Okay, then once they are able to improve the deployment frequency, the time to market is obviously going to increase. Okay, so since the companies are going to do much more deployment now, so they can bring on the features to the market much more quickly. Okay, so they can bring these features much more quickly. Now, doing the deployment doesn't mean that the failures are going to increase. No, you have to build an ecosystem where if the failures are there, okay, something is not working as expected, then it should be detected in the initial stages, okay, in the lower environments, and till the time we move to the production environment, then the failure rate should not increase. Okay, how this is attained? They create the DevOps individuals create multiple environments, okay, and some are similar, very similar to the production. So if things are working in the lower environment, then they will also work in the production based environment. Okay, this is where lower failure rate comes into the picture, and this is how they solve this issue. Okay, and finally there is a shortened lead time between the fixes. So let's say I bring in some change, okay, and something is not working and there is some bug which has been introduced. We were not able to track this in the testing part. Okay, might be we have not covered that test case or something like this. So uh, we should be able to put a fix, okay, in the smallest period of time after detecting an issue. Okay, obviously the developers are going to code for that, but once they have code, we should be able to automate and deploy it much more faster. Okay, this is where the CI/CD comes into the picture. Continuous integration and continuous deployment is going to solve this issue. So if some bug is introduced, we are going to apply the fix in the shortest period of time. Okay, and then comes the faster mean time to recovery. So let's say due to some disaster, okay, let's say some hardware failure or some other failure, our system goes down. Okay, so the architecture of our applications should be in such a way that it should auto heal. Okay, when I say auto heal, it means basically it should try to heal itself, the application, and it should be built in such a way that application is able to recover in the shortest period of time. So you will see that if you are using something like K8s, what is K8s? This is basically the Kubernetes. Okay, we are going to talk about the Kubernetes shortly. Okay, so you will see that Kubernetes is able to recreate the application containers after detecting if something is failing. It's going to terminate them and recreate them automatically. This helps in reducing the time to recovery of the application. Okay, this is one of the aspect, but there are other tools like Puppet, Chef, and Ansible which can help you to recreate the servers on demand and deploy the entire configuration on these servers from scratch. Okay, so this is going to reduce your time for recovery. Okay, and this will help in increasing the high availability of your application. And finally, you should be able to maximize the predictability. What is predictability? Okay, so let's say if I'm able to predict that my traffic is going to increase 2x time, then I should be able to scale my application according to that. Okay, And efficiency. So how do you increase the efficiency? Let's say I'm having a latency of 2 millisecond, okay, and tomorrow my traffic grows into 2x time. So this doesn't mean my latency should increase, okay. So my infrastructure should be able to handle these kind of traffic and still maintain the same kind of latency, which is very low. Okay. So this the infrastructure should be designed in such a way that the efficiency of my system should be retained. It should be secure. All the patches should be deployed. If there are some vulnerabilities, we are going to scan and fix them. Okay, we are going to use network firewalls, we are going to use SIEM tools and all these things to help improve the security of our system. And finally, the maintainability of our system. What is maintainability? See, all the infrastructure basically degrades after a period of time. So you will see that whether it's the operating system, whether it's containers, whether it's programming languages, so everything, newer versions keep on coming. Okay, so we are going to keep the infrastructure in a consistent way that we are able to maintain it with the latest versions which are coming, stable versions which we are coming. Okay, because they always fix on the bugs and the security issues. So it is necessary to upgrade them whenever these kind of systems are available. Okay, so these are the major goals which DevOps helps to realize, and all of them significantly contribute towards the organization's goals. Okay. All right. And here is a pictorial representation of what it looks like. So you will see that there were development teams. Okay. There were operation teams which were working in their own silos. Basically, both worked independently of each other. So this wall basically represents, okay, the silo. Okay. And they were not collaborating with each other enough, and this is where our DevOps comes into picture and try to remove this of in between, okay, and helps them to collaborate and understand both the systems effectively in order to overcome the issues for both. Okay, and here is an effective way on how the DevOps gets implemented. So businesses are basically responsible for coming up with their requirements. Okay, they are the ones who are going to decide what is required to be developed. Okay, so they come up with the requirements. Then developers, okay, development teams are going to use the agile development model to bring and code them. Okay, so they are responsible for coding the system. Now once they have effectively coded, okay, and then the DevOps teams are going to come into picture, and they are going to automate all the operations. Okay, this will be automated so that the applications can be quickly deployed into the production. All the deployment strategies, like in the lower environment to the final production environment, will be automated so that the live users are able to use it. Okay, so you will see this is how the DevOps gets implemented and helps in resolving the various challenges that the organization might face. All right, so now let's discuss about the Kubernetes. Okay, so the uh, Kubernetes is one of the latest technologies, okay, which was initially developed by the Google. So you will see that Kubernetes, okay, this was developed by the Google initially, and Google itself has been using the similar technology to run their infrastructure. Now, what Kubernetes does is it uses the containerized applications, okay, it helps in managing the containerized application. So you must have heard about a term called Docker. So Docker is an technology which basically helps to containerize an application. So whenever we talk about an application, okay, these applications are nothing but it's basically a combination of libraries and binaries. So normally you will see that these applications consist of libraries and binaries, and you effectively use these libraries and binaries to create your application. Okay, So various apps, whether it's a mobile application or whether it's a web application, it doesn't matter. You are always going to use these libraries and binaries. Okay, and what Docker does is it effectively it creates a runtime environment. Okay, so unlike the operating system, it just creates a runtime environment. It provides you with a runtime environment. Once you have uh, like put all these libraries and binaries and run the application inside these containers, okay, uh, you are able to ship the container to anywhere. Okay, you can ship the container from your system to the production system and it will run. Okay, so think like container is a way where you can put whatever your application requirements are directly inside it, and then Docker container is responsible for running that application. Once you have put your application inside a container, you can basically run it anywhere on any operating system out there. Okay, because Docker engine is available for all the operating system, whether it's Windows, whether it's Ubuntu, whether it's CentOS or any other operating system. So you can run it anywhere. Now, whenever we talk about these Docker containers, okay, so normally what happens, there is a issue, like let's say we are having hundreds of containers to be run on thousands of, or like we are having thousands of containers to be run on hundreds of nodes. Okay, so nodes are basically your server on which the containers are going to run. So what Kubernetes is going to do is it's going to help you in managing these containers, because there is effectively like how you are going to deploy the container. Let's say I have to deploy a container on a CPU intensive node. So I'm not going to go out and search between hundreds of nodes and determine what all nodes are having higher CPU, right? This is something which Kubernetes can do it for me. Okay. Not only this, it can also create the network. It can create load balancers. It can help me track where the containers are running. If some container gets stopped, it can automatically start it. Okay, so you will see that Kubernetes is an open source system. Now it's become open source and it is maintained by what we call CNCF. Okay, what is CNCF? It's a cloud native computing foundation. So Google has basically initially developed and then handed over the project. Now the effective development of the Kubernetes is being looked after by CNCF. Okay, and once you have deployed your application in the Kubernetes, you can basically run it on multiple hosts. Okay, that we already know. You can run it on more than one host, and Kubernetes is going to provide you a mechanism through which you can do the deployment. Okay, when I say deployment, you can basically create the containers on it. So you just define how many containers you need to run, and Kubernetes is going to do the rest for you. So if you say, create 10 containers, so Kubernetes is going to determine which all are the nodes where it's best to run those containers, what networking it requires, what is the image, okay, how to create the container, set up the networking, ship the logging. So all of these things, Kubernetes will do it for you. And it automatically comes with the rolling deployment. So you can do the rolling deployment as well as you can do the blue green type of deployment. So these kind of deployments are automatically built inside the Kubernetes. It supports both of these kind of deployments. So the deployment solutions are automatically built inside the Kubernetes. And then you can easily do the maintenance as well. So if you want to perform some patches, updates on your application, you can easily take it out and make the changes. Okay, then Kubernetes is going to remove and schedule the pod somewhere else, and once you are done, it will going to reschedule it. Okay, the pods on it, and you can easily scale out the application. So what Kubernetes does is it can provide you with the matrices. What is matrices? Basically, matrices means that it's going to provide, it can track the CPU utilization, okay, the memory utilization of these containers, and if they breach a certain threshold. So let's say if CPU utilization becomes greater than 80%, okay, then in that case, it's going to increase the container count, let's say from 4 to 6, for 4 to 6. What will happen if more containers are there? Then it can take more amount of load, so CPU utilization will come down to, let's say, 60. Okay, so these kind of scaling is built inside the Kubernetes, and it can automatically handle these kind of scalings in real time. Okay, you don't even have to be available. You can configure all this inside the Kubernetes, and it can automatically do it for you. All right, that was about the Kubernetes. And if we look at the Kubernetes, you will see that the adoption of the Kubernetes is increasing day by day. So large number of companies are actually moving towards the Kubernetes. It has seen about 200,000 2000% growth, okay, on how it is being used. One more advantage of running the Kubernetes is that you can basically run it in anywhere. So you can run it on cloud, okay, you can run it in your data centers, okay, so you can easily run it in your data centers, and finally you can even run it in your virtual VMs, okay, so you can even run it on virtual machines. So what is happening now? See, because the Kubernetes is able to run anywhere, okay, so uh, it doesn't make the application dependent on some cloud provider. So it basically means that if I have today deployed my application on, let's say, AWS, and I'm running Kubernetes, tomorrow I can move to Google Compute Cloud, okay, to Google. And if I want later, I can come in my own data center inside the virtual machines, okay, so my application doesn't become cloud dependent. But if you are not running Kubernetes, then eventually it creates a kind of a locking mechanism, after which you will not be able to run your application inside the other clouds like that, okay, it becomes too much integrated with their APIs. Okay, so this is another advantage why the Kubernetes is growing and why the organizations are heavily using the Kubernetes. So even if they are working in clouds, they want their application to run inside the Kubernetes. Okay, and you will see here are some of the interesting facts about the Kubernetes. So it will show you how much active development is happening inside the Kubernetes. There are like 24,000 contributors towards the code part of the Kubernetes. So you will see there is continuously new functionality which is being added inside the Kubernetes. Okay, there are 148,000 code commits each month. Okay, then there are 83,000 pull requests which are there. So think of this pull request as the new features which the people are contributing. Why? Because it's an open source project. So people are contributing all over the world towards the development of the Kubernetes. Okay, so the development is happening at a very rapid pace. It is bringing lot many features in the Kubernetes. And then there are 1.1 million contributions which have already happened to Kubernetes, and there are 1,744 companies which are actually contributing. And this is this keeps growing. Okay, so as I already told you that there is a huge demand for people who are having the knowledge of Kubernetes and how application can be containerized. Okay, this has actually revolutionized how the application are running now. Okay, all the traditional way of running the applications has been moved away. Okay, now this brings us to the different kinds of architecture. Okay, with the introduction of the containers, it become easier to create the microservices kind of architecture. Okay, so what is microservices kind of architecture? Let's try to understand it, because the true potential of it can only be recognized using the containers. Okay, so let's talk about this monolithic architecture first. So this was used like before 2010. Almost all the companies were working on this monolith kind of architecture, and all their applications were designed with a monolith kind of approach. So what is a monolith approach? Let's try to understand it. So let's say we are having a e-commerce firm. Okay, e-commerce firm, something like you can think of like Amazon.in or Flipkart. Okay, so what they does is they used to sell the products on the internet. So you will see that they are having different components for running the e-commerce. Like there is something known as catalog. Okay, so what is catalog? Catalog is basically the one which shows all the products that they are offering. So they are going to have a service called catalog. Then they are going to have a service called cart. Okay, so whenever you purchase any product, you are going to move that product inside your cart. Then they are going to have a service called uh, like notification. Okay, so what is a notification? Anytime you purchase a product, you are going to receive an SMS or like mail. So these are called notification. Then they are going to have something like rule engine. What is rule engine? On basis of which the various decisions in the system are going to be taken. Okay, so it determines that this is the process and this is the rule which has to be followed in order to book some process. So like if the pin code is delivered or not. So these kind of services are there. So what's happening right now? We can see that this, for building an e-commerce, we have to create 4 types of service. So in a monolith kind of architecture, what used to happen was that all these 4 services will be clubbed and created as one application. Okay, they were tightly integrated with each other. Okay, and they are going to be created as one application. So what is the advantage? So see, the first advantage is like, because you are running it as one app, you don't need that many servers to run on. And it's easier to code because you don't have to worry about how the catalog is going to communicate with the cart. Okay, so what is the downside of this architecture monolith? Let's say there is a catalog team which is working on some update. So they are bringing some feature and they updated their application. So it's possible that something goes wrong and this service goes down. If this service goes down, then entire application goes down. Okay, even this was true with the cart. Okay, or notification. So although the other teams are also working, okay, they haven't introduced any change, but everything is so tightly coupled with each other that if one of the system goes down, then entire application goes down. So it reduces, from the architecture perspective, you will see that this is like it's a single point of failure, and if something fails, then entire system will go down. Okay, and your customers are going to get noted this, and they will see that entire application is down. So this is not very scalable, so it is not used now, and you will see that people are moving away from monoliths. Okay, and after that comes a SOA approach. Okay, so what is the SOA approach? See, what up till now in monolith, what used to happen was that it was not that much scalable as well. Okay, why it was not scalable? So let's say I have to just increase my cart servers. So I can't increase my cart servers only. I will have to increase all the services because all the services are heavily dependent on each other. So later the SOA approach came into picture, which basically tried to create application on multiple servers. So think of it like this is one server, this is second server, this is third server, and this is fourth server. So what is the problem here? The problem remains in the fact that still the application is very tightly coupled. If something goes down, entire infrastructure goes down. So only advantage of SOA was that if this server goes down, and at least my application doesn't goes down. Why? Because one server is down, then rest are working. So it will continue to serve. What is the problem? If one service goes down, something bad happens to the service, then entire service goes down, right? Because they are tightly coupled. Finally, we came to microservices. Under the microservices, what happened? We basically divided them up like each service. Okay, so we can think of it like this is a cart. Okay, So we deployed the cart separately, we deployed catalog separately, and then we use the communication. So they will talk to each other like a individual services. So basically, it's not one service now. This is a combination of 4 different services, okay, which are individually managed by each team. So we are not having one team to manage all the 4 now. Instead, we are having separate team. What is the advantage? Since one team has to manage one type of application, they can better focus on it, okay, and they can bring on the develop like features into their application much more faster. And suppose now this card goes down, so there is no problem, rest of them will keep up and running. And let's say notification goes down, so what is the impact? If notification goes down, customer might not receive messages, okay, or mail. So if they are not receiving mail, it's somewhat fine, okay, at least entire system is not down, people are still able to purchase the products. So this this kind of architecture, okay, helped in increasing the availability. So availability of the system got increased. Okay, what is the disadvantage? See, large amount of servers was needed for creating this. Large servers were needed. Okay, but Docker has actually solved this problem, because now you don't create these services separately on servers, you actually deploy them on containers. Okay, so multiple containers can run on one server. Since you are deploying them each inside the containers, and which is like managed by Kubernetes, okay, so you have already overcome the issue. Now you don't need that many servers, and you can still run it separately without causing issue between each service, right? That's why you will see that microservices kind of architecture, organizations are now moving away from monolith architecture towards the microservices kind of architecture. All right, here is how you basically scale out a monolith architecture. So you will see that basically all the services, like these are all the services which are deployed onto a server, and then you start creating multiple copies of the server out of it. But the problem is, if you just want to scale one application, okay, if I wanted to scale one application, I can't do this. Okay, I can't scale one application, I have to scale all the applications, and beyond a limit it might not be possible to scale all the application. It might actually cause more issue than solving the problem. So that is the issue with the monolith scaling. Okay, and here is what the monolith development lifecycle looks like. Okay, so you have the developers, they are going to build an app. Okay, so these multiple developers are building this app, and this is a delivery pipeline, how it looks like. So they are responsible for build, test, and release. If something breaks, then entire system goes down. Okay, so monoliths are no longer used. And this is a microservices kind of architecture. You have different services like an order UI, user UI, shipping UI, shipping, and then this is an order service. Okay, so there are multiple services now, and each running individually as an individual service. Okay, so no longer we are combining everything like one service, they all are individual services, and each individual services talks to each other individual services in their own way. Okay, so this is what the microservices kind of architecture looks like. If one service goes down, only that service is affected, the entire ecosystem is not affected. Okay, all right, and how do you scale? See, you will in this architecture, you can scale each application according to their requirement. Like we have scale order UI separately, we have scale order service separately. Okay, now you will see there is a significant difference. Like this is running 3 servers. Okay, this is running 2 servers. Okay, this is running like 7 servers. So you will see that with the microservices kind of architecture, I can scale out individual services according to their own requirement. It's not like that user UI requires only 2 servers. Okay, but I'm still running 7 servers, because in monolith I would be doing this. Okay, so this is no longer the case. Okay, it's always like each service can scale individually. So that is the advantage of running the microservices kind of architecture. Also, it's easier to understand how the services are interacting. If they are tightly coupled, it's very difficult to think of the entire system as one. Okay, but what is the issue that you will see from a DevOps perspective? That over a period of time, your infrastructure will look like this. So you are going to have lot many more servers. Okay, so you see this is huge number of servers to be maintained, and this is where the DevOps practices will come into the picture. And DevOps are the people who facilitate this microservices kind of architecture, because they have automated the entire container creation process or the server creation process, build and automation. So if you want to run on this scale, if you want to run on scale, you require DevOps. It's not possible to run the applications on scale manually. You need to have the automation built into it. Otherwise, you will not be able to handle such a big kind of architecture. So we saw that there are numerous advantages to microservices kind of architecture, but it can only be implemented when you have successfully implemented the DevOps practices. Otherwise, it will not be possible for you to run on such a scale. Okay, all right. So there are some other challenges as well, because it can be like you are running like 10,000 servers now. Okay, so monitoring of these 10,000 servers also becomes very problematic. Okay, and also it will be very difficult for you to know which server is healthy. So out of these 10,000, let's say 100 services are not healthy, they are not running, 100 containers are not running. So it becomes very difficult for you, right? So you can't determine manually like how many containers are down or something is not running. In this case, monitoring should be effective, and this is where the DevOps practices comes in. So they are going to monitor everything. If something goes down, you are going to get an alert for it automatically. So monitoring 10,000 servers becomes a challenge, which can only be solved by the DevOps practices. And how do you manage the performance of each individual service? Let's say I'm having these 10,000 services, out of which, let's say 1,000 services are having a response time of 5 minutes, or let's say let's have a response time of 3 minutes. Okay, so no person, okay, no customer is going to wait for 3 minutes to just a page to load, right? So these kind of latencies are not basically adhered to the any significant customer retention, right? So it's very difficult to track which services are going down in latency. Again, this is something which the monitoring can resolve for you. And finally, if you have to debug a service, it will also become a challenge. So as the size keeps on growing for your application, as the business grows, it becomes more and more challenging to uh, you know uh, mitigate these kind of issues. And this is where the DevOps practices can really help you out. And then there is service discovery. Okay, so what is the service discovery means? Okay, let's say I'm having thousands of servers running. Okay, now obviously each service is having a URL associated with it, which is called as endpoint, through which that service replies. Okay, so let's say we are having a service A running, and then there is service B and service C. So it has to interact with service B and service C. A has to interact with service A, B, and C. So how does it know that what is the endpoint it should connect to? Okay, because the containers keep coming up and going down, right? So it's not possible, right? This is where the service discovery comes in. So what is service discovery? Service discovery, through with service discovery, it automatically discovers that there is a new service, and it automatically identifies the endpoint for it, and it uses that endpoint to connect to it. So think of it like a dynamic environment, okay, in which endpoints are automatically created and it can automatically figure them out. This is what the service discovery looks like. And So Kubernetes has this service discovery built in, and you can eventually use them. Okay, and then also the challenges are going to come towards how you are going to independently load balance the service. So what happens? You are having a service. Okay, let's say I'm having uh, 3 containers. Okay, so if I have to, all these 3 containers are similar. So all these 3 containers are uh, similar. If a request comes, this is a request. So I need a load balancer to send the request to each of the container one by one. Okay, so first request goes to this container, second goes to this container, third goes to this container. Okay, now if you are using this approach, then how do you know that this service requires scaling? That is, more containers needs to be added to it. And how do you add it? So these kind of challenges you will face. So let's say this requires 4th container. So how do you understand that which containers requires to be scaled up? So this is something which service discovery is going to help you out with. Okay. And finally, if you have to create newer servers for running more load, then how do you understand that you need to scale up your infrastructure? Again, this is where the service discovery is going to help you. Okay. All right, then comes deployments. So see, the number if the number of servers are going to be large, then you will have to first go ahead and do the development, and then do the testing and deployment, right? And because you are having like thousands of servers, so all of this should be automated, and you have to figure them out at the runtime, right? So managing deployments on thousands of servers can be challenging, and you need to have the proper tools in place like Ansible, Puppet Chef, or Kubernetes, which can help you achieve them significantly and do the deployment as required. Because if you try to do it manually, you can't deploy in thousands of server altogether itself. Okay, and then there are the services are not it's not the same kind of services you are running everywhere. So it will be using different languages, like some will be using Java, other one are using Golang, someone is using Python, right? So you will have to create the process around different languages. It's not possible for you to run these different kind of uh, services running in different languages manually. You will have to use some automated way in order to manage these different kind of languages. Okay, their build, their deployment, how they are going to build and deploy. So all of this has to be automated. And finally, you have to decide on which servers you are going to run this, and they might have some specific requirement, like application requires 4 GB RAM and 4 core processor. Then you have to identify on which server it is available. You are not going to do it manually. If you are going to create thousands of servers like this, you need some way through which it is automatically it can be done automatically. And this is where the DevOps practices are again going to come up the picture. So these are like some of the examples, some of the challenges which DevOps helps in overcoming. Okay, so once you are well versed with the tools required for effective implementation of DevOps, you can answer all these challenging questions. Okay, and for all these questions, the solution is towards, I already told you that there is a way of all these questions can be answered using the Kubernetes, which runs the Docker container. So Kubernetes basically runs the Docker container, and all the above questions can be easily be overcome using this. All of these features are built inside the Kubernetes. So that's why the organizations are creating so much focus on implementation of Kubernetes now. Okay, and here is an architecture to show you how this basically works. So developers start by coding. They are going to put their code inside GitHub. Okay, this is basically a repository for code maintenance. So everyone is going to commit all their code inside this repository. Okay, Then out of it, we are going to take this code, we are going to create the images. Okay, what is images? Think of it like a blueprint of creating the container. Okay, for creating the container. Finally, once you have the image, then you can push it to the Docker Hub. What is Docker Hub? Docker Hub is again a repository of images. Like the GitHub was repository of code, this is repository of images. Okay. And finally, once you have the images, you can push it down to Kubernetes. Okay, and Helm is a package manager, so you can write the configuration in Helm and deploy them on anywhere, any cloud that you want. Okay, because Kubernetes runs similar in all the clouds, so you can deploy in AWS, Google, or Microsoft, or you can deploy all three of them using the multi-cloud strategy, which is becoming more famous now across the organizations. Okay, so this is how the microservices deployment architecture looks like. And finally, like I would like to confirm you that Google has been using the Kubernetes for the last 12 years. So it's pretty much developed. And this is why the Google Cloud is one of the most used one. You will find that most of the Kubernetes implementation is done there, because Google has a significant experience in running the applications over the Kubernetes. And here is an important statistic for you. So Google basically runs 2 billion containers per week. Just think like what is the size of their infrastructure looks like. Which helps them simply manage the containers, it helps in the performance, isolation, and efficiency. So they are running such a big infrastructure over the Kubernetes. So this is how much scope is there inside running the Kubernetes in your organization. And finally, if you are using any of the Google application, whether it's Gmail, Maps, okay, or even GC or any of the Google Cloud application, they are running inside the containers only. Okay, so in Google, everything runs inside the containers. Okay, all right, thank you everyone. We are done with our session. Okay, if you are having more questions, I will suggest you to get in sync with the Cognixia support team. And now we are going to wrap up the webinar till here. You can send in your mails or contact the Cognixia support team. They will redirect your questions to me. Okay, thanks everyone for attending today's session. I hope that you liked the session for today. Okay.